Ahmed, Shazia, Zainab, can you hear me?
Yes, sir.
अच्छा चलो metals we'll just try and complete this that we had to talk about reactions with water of the reactivity series. ठीक है, remember recap क्या था कि what did we do? We just basically did the reactivity series, which was that group 1 was very reactive, group 2 slightly less reactive, group 3 even less, and then transition metals were the least reactive. ठीक है. Now so we started doing the reactions with water. And I told you that group 1 is going to have like really, really explosive, vigorous reactions. Sodium is going to react very vigorously with water and it will form a very strong alkali. And they're going to ask for observations. And the observations are that sodium would float and fizz on the. This is very important. It almost appears in every paper, which is the observations and the reaction of group 1 metals with water. So it will float on the surface. It's going to have vigorous effervescence produce. A strong alkali would be produced. And NaOH is a very soluble compound. And sodium would melt and catch fire and it would explode. And down group 1, the reactivity increases. So you're going to have even more vigorous reactions with potassium. As a calcium pe, the reaction was slightly slower. It was slow with cold water, but it was very vigorous with hot water. Okay, and it would also form calcium hydroxide, something similar. With magnesium, the reaction slowed down further. There was there was almost no reaction with water, but instead it was reacting with steam at very high temperatures. So magnesium would react with steam and it would produce a white solid, which is magnesium oxide. And up here, lower in the reactivity series, when you reach aluminium absolutely had no reaction. I say, ye to 100% in almost every paper, they're going to ask you this. It's going to be a 2-mark question where they're going to ask you, KB, almost, why is aluminium not reacting? So in this one, it's absolutely no reaction with water. Why? Because aluminium is kind of reactive, but it forms immediately an oxide layer, which covers the entire aluminium. And that layer, that coating is non-porous, which means nothing can go through it. It's very unreactive and it's very tough as well. And that kind of protects aluminium. So your aluminium foil or your aluminium tin cans, etc., they generally tend not to react. So यहाँ पे लिख भी लो कि so this is very helpful in some uses that AL aluminium food containers, example cans, etc., and car bodies, bicycles. Yeah, so the reason you use them is they don't react or rust. ठीक है. अच्छा, so keep this in mind about aluminium. ये clear है Taha, Hania, Nabila, is this clear?
Yes,
Yes,
sir.
sir.
अच्छा फिर then you have uh, these elements over here. Very, very slow reactions with water. I mean, basically, when I say slow, that means they're going to take years. Iron would rust, but it's going to take many, many years for that to happen. Very, very slow reactions with water. And below H, almost no reaction. You get below H, the reactivity decreases so much that you're not going to have cold is not going to have any reaction. ठीक है. अच्छा, लेकिन there's one element which you have to study in detail, and that is the rusting of iron. You're going to get big questions on this. It's kind of important. TK, you're going to get a 3-4 mark question on this. So rusting of iron. Again, it takes years for iron to rust. So it's not a very fast reaction, but since we use a lot of iron, it's a reaction that's kind of very important for practical purposes. As a rusting of iron, what is the reaction? Uh, the essential requirement is that you need water, moisture, and you need air. So there has to be moisture and there has to be air. And it will rust. It will form a red-brown powder, okay, which would be Fe2O3, or it could also be FeOH3. Okay, that's your red-brown rust, which is very porous as well. Okay, things can get through. So iron keeps on rusting. Once it starts rusting, it continues to rust. So so this thing basically, unlike aluminum oxide, this thing is like very brittle. Okay, rust breaks off and iron corrodes. Okay, so that's what rust is. Remember this equation. Okay, this equation is very important, and this is very important. Okay, what are the essential conditions for that? Yes, I'm going to add one thing, and that is okay, at higher temperatures, I mean, you can also add higher temperatures as well. In warmer tropical conditions, ठीक है, ऐसा कराची है, ठीक है, things will rust very, very quickly. Uh, which is actually true because if you buy any car from Karachi or has a Karachi number, it will rust very quickly within 3 or 4 years, and there's going to be significant rust that's going to build up on that car. ठीक है? अच्छा, similarly, rusting would be nee, that's enough. Nee, Fe2O3, FeOH3 is kind of the same thing. ये जो है ना, remember, oxides and hydroxides are kind of almost the same thing. ठीक है, ये बल्कि I'm going to write this point that oxides, hydroxides are almost the same. For example, I've got calcium oxide. If I add water to it, it will become calcium hydroxide. And vice versa, if the temperature is too high and I remove the water, it will turn back into calcium oxide. So it depends on the amount of water that's present. If there's a lot of water, the calcium oxide will turn into calcium hydroxide. If there's less water, any dry conditions, then the calcium hydroxide would turn into calcium oxide. So keep this in mind. Oxides and hydroxides are kind of the same thing. As the bigger question is preventing rust. The method number one, that's called the barrier method. As a barrier method is, you want to protect iron from oxygen and water. So first thing, paint it. If you paint, that's why cars are painted. Because if you paint them, the water and the oxygen will not be able to. So the water or the oxygen should not be able to reach the iron. ठीक है, ये clear है? Ibad, Fatma, Nabila, is this clear? Hania, clear? Here, is this clear?
Yes, sir.
अच्छा,
Yes,
so
sir.
so barrier method, and remember about barrier method. It's a small scale method, which means like if you're painting something, So you can't, if it's a very, very tall building, let's say it's a 120-story building, it's pretty hard to paint it or keep it painted all the time. If it's a big bridge, it's pretty hard to keep it painted all the time. So paint will only work if it's a small thing, okay, you can maintain it, but at on a larger scale, you can't do that. Eiffel Tower, you can't 100% ensure that it's always painted. So so these are all small scale uses. I said there's oil and grease that can be grease, if you're spelling it's EA, or wax, right? So there's a thin layer of oil that kind of protects it from water and oxygen. Again, that's small scale. ठीक है, bicycle की chain है, you can use that for that. Uh, a more expensive barrier method is electroplating. We did electroplating early on. So electroplating is done normally to make things look good with gold, silver, copper, something that's unreactive. So for example, you've got a watch that's made out of let's say that's made out of iron. Oh, please, 1 second. I said, so we've got this watch over here, and so there's going to be a thin film of gold on top of it. So that would kind of keep it protected. Gold is very unreactive. So barrier method, it's going to be a coating. Now the trouble with the barrier method is that if the coating breaks, the barrier method fails. So if the coating breaks, there's a gap, then rusting would start. ठीक है, गाड़ी होती है ना, तो उसमें if the paint breaks off, that's where the rusting would start. ठीक है, तो ये clear है barrier method, is that clear?
Yes,
Is it not?
sir.
Okay, the second method. Now that one is called I mean it's got different names. The second method is like a more permanent method. इसका नाम क्या है? We're gonna call it sacrificial protection. I said now they're gonna ask you 2-3 mark question on to describe sacrificial protection. Now in this one you don't always have to code it completely. First thing. And at least completely. ये completely code करने की जरूरत नहीं है. Uh, so even if a connection is there, so for example, there's an iron and you can connect it with a slightly more reactive metal like Mg. So Mg or zinc are normally used. Here, this is also known as galvanizing and also known as cathodic protection. So what happens is, okay, this is like a cell, Mg connected with Fe. Who's the more reactive in दोनों में से which one is more reactive? Ahmed, Mg और Fe में which one is more reactive? Ania, ज्यादा reactive कौन है?
फिर magnesium.
ठीक है. So magnesium is more reactive, and the more reactive one wants to lose electrons. So Mg would start to turn into, it will start to turn into Mg ions, and it will start to lose electrons. It likes to lose electrons. So there's going to be a lot of electrons on this side because Mg would not be in control of its outer electrons, and a lot of them are going to be lost. And those electrons would then travel all the way towards iron because iron is less reactive, right? So iron would not be losing electrons. So on one side, there's a lot of electrons that are being lost, and they'll travel to iron. So if oxygen or water try to gain electrons from iron, then iron wouldn't have to lose electrons because, I mean, it can simply pass on these electrons to oxygen and water, right? I mean, that's what rusting is. Balki, let's add this over here as well, that iron is the one that gets oxidized, which means it loses electrons. Iron over here is the one that's turning into Fe+3. Okay, so it's losing electrons, and it's losing electrons to what? It's losing electrons to water and oxygen. Oxygen is becoming -2, or water is becoming OH-1. So they're gaining electrons, right? So वो भी I'm going to add it over here. Is that clear? So water and oxygen are the ones that are gaining electrons. I say anyways. So water and oxygen wanted to gain electrons, and iron was supposed to lose electrons. But in the presence of Mg, even if iron tries to lose electrons, it's going to get more electrons from Mg. So iron will not be able to lose electrons. Indirectly, it's always Mg that's losing electrons. So is this idea clear that iron in the presence of Mg will be unable to lose electrons? Is that clear?
So what will O2 and H2O do?
गेन करते हैं ना इलेक्ट्रॉन्स.
नहीं आयरन के साथ वो क्या करेंगे?
क्या करेंगे?
आयरन और लाइक ये जो आयरन आपने लिखा हुआ है ऑक्सीजन और वाटर,
हम्म.
ये क्या करेंगे सर इसके साथ? लाइक ये अब लाइक इसके साथ रिएक्ट
ये
नहीं करेंगे?
मतलब वो करेंगे तो सही, इलेक्ट्रॉन्स वो गेन करेंगे ना, दे लाइक टू गेन इलेक्ट्रॉन्स, राइट? देखिए वो इलेक्ट्रॉन्स कहाँ से आ रहे हैं? एमजी से ना. तो बेसिकली एट द एंड ऑफ डे क्या हो रहा है? व्हाट्स हैपनिंग? mg is the one that's losing electrons, right? Clear? And oxygen and water are the ones that are gaining electrons, right? So they are turning into negative ions. Okay, so basically nothing happened to iron. And the products that would be formed would be, well, the combination. It's going to be Mg plus ions and let's say OH minus ions are getting formed. So it's going to be MgOH2 or Mg plus 2 ions combining with the oxygen minus 2 ions, and they'll form MgO, right? Is that clear?
जी
Zarar,
सर.
Zarar clear है?
जी सर.
Yes,
तो वो
sir.
rust ही, so rust will not be formed. Iron would do nothing basically. ठीक है, nothing would happen to iron. So so nothing would happen to iron. So you have to describe this, right? So there has to be an electrical contact. ठीक है? So Mg, so how would you describe it? So if it's a 3-mark question, Mg is more reactive, and loses electrons more easily. As compared to Fe. So electrons from Mg would travel towards iron. And the last thing is, so if water or oxygen try to oxidize Fe, if they try to gain electrons from Fe, what would happen is then electrons gained by water or oxygen would indirectly come from Mg. Is this clear? They indirectly come from Mg, and iron will not be rust, would not be rusting, or will not rust. ये clear है? Is this clear to everyone?
Yes, sir.
ठीक है? Hania clear है? Zainab, Ahmed, is this clear?
Yes, sir.
Yes.
Achha, and so keep this in mind. This is called sacrificial protection. It can happen with I mean, you can use Mg or zinc. You're not going to use uh, and remember, this is large scale. This is used like you've got a huge shipping vessel. So you're going to attach pieces of magnesium on it, and you would have to replace it over time. Because Mg would slowly rust, and Mg will dissolve and turn into ions. So the Mg piece will go away. Once that is gone, then iron will start rusting. Iron would have to lose electrons if there is no Mg left. So Eiffel Tower or bridges, big bridges, they are coated with magnesium. You don't necessarily have to coat it. Even if you just have an electrical contact, that's important, that the electrons should be able to travel from one side to the other side. As anyways, there's a similar one, and that's called cathodic protection. So cathodic protection is that it's a very similar idea. It's cathodic protection is that in that you use a battery. And whatever you're trying to protect, for example, there's an oil rig. I'm going to try and so let's say there's an oil rig at sea, and that oil rig is made out of iron. So you connect it to the cathode of, let's say you've got a battery, or you've got any electrical device. The cathode is the one that's sending electrons. So this thing over here is getting electrons, but from the battery. So the battery has stored electrons and it's sending electrons. So if oxygen and water try to gain electrons, then iron will not be the one that would be gaining electrons. Those electrons are coming from the battery. So as long as the battery is providing electrons, oxygen and water will not be able to gain electrons. I mean, they will not be able to gain electrons from iron. Is this clear? Iron gets protected. Is that clear?
Yes, sir.
Here, obviously, the side will be, attached to something. We don't care. So, but it's a very, very similar idea. ठीक है, clear है?
Yes, sir.
Yes, sir.
Okay, so that's cathodic protection, where instead of magnesium, it's the battery that's doing the whole work, right? So I'm just going to write that. So similar to the piece of magnesium, battery sends electrons constantly to Fe, and therefore Fe will be unable to lose electrons. So ठीक है, so this is cathodic protection, and that's all rusting of iron. ठीक है, remember barrier method, and then you have sacrificial protection or cathodic protection. ठीक है? जो ये clear है, Taha, Ebed, Hania, Ibad, Zara, clear? Is this clear? Nabila?
Yes,
Yes,
sir.
sir.
Yes.
Okay, so that's all about water, right? Let me just recap. The first few, very explosive reaction, right? Need rusting prevention के लिए. Chances, this is how you prevent rusting. As a first few very reactive, calcium slightly less reactive, magnesium starts reacting with steam, and then you have very, very slow reactions, right? And the rusting of iron, you need to know the equation. You need to know the methods preventing it, painting it, grease, wax, etc., electroplating it with gold, silver, etc. These are small scale uses. They work, but the moment the barrier breaks, rusting would start. ठीक है, bicycle chain में, if you stop oiling it, the barrier would break. There wouldn't be any barrier like after 1 week, and it will start rusting. Sacrificial protection, we did that. As in, now the next thing is we're going to do the reactions with acids. Now, the first thing is you should know that metals, when they react with acids, so what happens to them? They produce salt plus H2 gas. Okay, so what would you observe? You're going to see bubbles of H2 gas being formed. As anyways, now the reactivity series. As Air, then an Fe. As anyways, the thing. Now, we're going to keep this simple. The first three,
थोड़ा ऊपर स्क्रॉल करेंगे
मैं कर रहा हूँ एक सेकंड. ये
ये सही
as a first three, very explosive reaction. Okay, so you're just going to see a large explosion happening. It's going to be very explosive. So, for example, sodium with it's going to form NaCl plus, but it's just going to be it's going to simply explode. The moment you add sodium to an acid, it will explode. शांति में निमोनिक मैं दे देता हूँ वैसे। ये जरा क्या क्या निमोनिक था हमारा?
सर बता दो वो वाला।
नहीं वो तो नहीं तो मैं एंड में क्या था उसका? एक तो आसिफ जरदारी फ्रॉम सिंध पाकिस्तान।
ही इज क्यूट ऑनेस्ट एंड अमेजिंग पर्सन।
शान से कोई भी बना लो, ठीक है। एक हमने बनाया था के, विच वॉज KNACMG, ठीक है। इट वॉज
आशिफ
आसिफ।
ने कार मांगी। आसिफ अली जरदारी फ्रॉम सिंध पाकिस्तान, ही इज क्यूट ऑनेस्ट एंड अमेजिंग पर्सन।
आसिफ क्यों जरदारी फ्रॉम, आई मीन यू कैन जस्ट मेक योर ओन, ठीक है। सिंध पाकिस्तान। अच्छा उससे आगे क्या था? ही इज क्यूट ऑनेस्ट एंड अमेजिंग। अच्छा दिस इज वेरी पाकिस्तान स्पेसिफिक, ठीक है। अच्छा यू कैन जस्ट कम अप विद एनी निमोनिक। इसका स्क्रीनशॉट ले लो, मैं डिलीट कर देता हूँ ये, ठीक है। लेकिन अब इजीएस्ट जो है ना, दैट्स जस्ट कीप रिपीटिंग KNACMGLZNFESN PBHCUHGAGAUPT। तो ये भी वैसे भूलता नहीं है, ठीक है। अच्छा एनीवेज, चलो ये फिर ना विल अच्छा फर्स्ट थिंग, द फर्स्ट थ्री are going to have a very explosive reaction, ठीक है। अच्छा then the next three, ये वाले Mg2, not the next three, Mg2 10, ठीक है। Mg2 10, you're going to remember them as mazet, magnesium, aluminium, zinc, iron, and tin. So they have moderate normal reactions. I mean, you can do these reactions in the lab. These are like safe reactions. For example, you've got magnesium reacting with HCl. It's going to do what? It's going to produce MgCl2 plus H2 gas. So very no moderate reactions. So keep this in mind. कि mazet जो है, those are going to be really normal reactions. Below H, there would be no reaction with dilute acids. ठीक है, so no reactions with dilute acids. Uh, but they can react with very concentrated acids at very high temperatures. It's not gold, and gold does react, but for gold to react, it requires a very, very concentrated acid. But it's extreme conditions for gold to react. ठीक है। Uh, lead also a very slight reaction. So ठीक है, we're gonna end it here, ठीक है। Just remember the important thing is mazet. Mazet, the middle metals, magnesium, aluminium, zinc, iron, and tin, these are the reactions that are going to be normal and they're going to be moderate. The top ones are going to be explosive. The bottom ones, they're not going to happen with dilute acids. So, well, that's it. That's the reaction with acids, ठीक है? Is that clear? तो कल से ना, tomorrow we'll start with extraction, metal extraction, ठीक है? यार, okay everyone.
अल्लाह हाफिज सर।
अल्लाह हाफिज।
सर।
अल्लाह हाफिज।